Okay, welcome back. We're on question 12. So clearly sets question the whole way through. So A, B and C are three sets. Yes, we can see them. Complete the table below by using set notation to describe the set illustrated by the shaded region in each of the Venn diagrams. So we have a three set Venn diagram here, and we have a shaded region up here in the A only section. So I got to think, what do I have to remove from A? And I'm looking at B union C needs to be removed. So we'll start off with A. I'm just going to open up my sets, my log tables here to get the notation that I might need for sets. Let's say I've forgotten a few things. Can't remember the notation. So if that happens to you and you're doing sets, you give yourself a fighting chance of remembering stuff by opening up and reminding yourself of all the notation on page 23. So here's our set notation that we were learning off in class and so on, or hopefully. So but the point is, it's all here and it tells you what it is. You know what the intersection thing is. You know what the union is. So if you understand the English language, then you can get reminded of the notation. Here's the difference, and this is the one I just wanted to remember here now. I said A. Okay, you know I did remember it probably in my head, but I want to show you, if you're a student and you're struggling to remember, you go to page 23 in sets and it reminds you of an awful lot. Okay, so A without, I want to remove part of A, and I want to remove all of this, and all of this I'm going to get with this union here. Okay, so I'm going to union B and C, and because I don't know about the order of operations, I'm going to use the super tool of brackets. Brackets always say prioritize, so make sure you connect them cross like this with a union before you set difference away from it. So A without, B union C. Now you can do them backwards, but it'll be quite unnatural because they're just the letters. So this is commutative, so it can be swapped. This is not commutative, it must lead with A without. Okay, and that's that bit done. Now here we need to have, this bit, which is disjointed, but we need, except for this tiny place here, but we need to get it. So first of all, we can see that it's most of A union. Okay, so I can write down A union B, and now I can decide to remove A intersection. Now just in case, I'm going to say I would definitely want that done first, and now I want to remove the intersection. Again, we have the intersection symbol here on the left and the union symbol here. So I'm going into another bracket and I'm saying get me the intersection between A and B. Once you've got it, remove it from the union and you get this. Okay, now this is going to be, so we're heading in now to a bit of problem solving with a Venn diagram, and this is probably going to be based on the exclusion principle, which is to do with how much stuff you put in the middle depending on whether you're trying to maximize or minimize. Okay, so let's take a look, follow a problem solving procedure. So a bookshop has set up two display stands of cookery books and sports books. So I have some sort of display stand with nothing but cookery books here and sports books. Now when I say here, let's find out what the diagram is about. On a particular day when 120 customers visited the bookshop, that's probably going to go there in a second, the 120. 22 customers bought, here comes the cat again, now that's 22 customers bought at least one cookery book. Okay, 22 customers bought at least one cookery book. So I think we have 22 people bought cookery books. They might have also bought other books. I think there's a 22 there. Here she comes. And we have 120 here. Okay, and 19 customers bought at least one sports book. I think we've 19 here. Well, I keep going. I can't. You're in the way. Come on. She's sitting on top. Right. She's sitting right on top of the page. And we've 120. Okay, so that's done. These are really important. I hope I got it right. Now, 70% of the customers who visited a bookshop did not buy a book from either display stand. Wow, 70%. Okay, let's calculate. So aren't they coming out here, right? They're in neither. So we get 70%. That's 0.7 multiplied by 120 is 84. So we'll put 84 here. So these are cardinal numbers. Work out how many go in the middle. Okay, so if there was none in the middle, that's what we're going to assume. We assume there's none in the middle and we see how many we have too much. And whatever we have too much by that assumption, we're going to put that amount there. See what I mean? It goes like this. It goes real simple. Now here's a case of, do I have to write stuff down? Like, I could, but if you picked up your calculator now and started saying, I'm just going to, I want to calculate this. Let's say I'm towards the end of the exam and I'm in a really big hurry. So I go 120 minus 22 minus 19 and minus 84. Okay, it's negative, but I'm telling you now that for sure is this is 5. This intersection is 5 because that way you've counted it twice and we've ended up negative 5. Now we're only going to count it once because instead of it being the 5 being here and here, they're here. So that's how it works. Remember who bought at least one book from each stand. You may use the Venn diagram below to help you answer the question exactly. Now then they could often then go on and ask, we could continue solving it, but that's going to give you full marks in this question. Okay? But it's hard not to keep going, so I'm going to keep going just because of the sake of that's what we do. We're mathematicians, we want to finish our Venn diagram. So 5 away from 22 is 17, and 19 take 5 is 14. I just want to show you one other little piece of extra notation. We know we put the solid dots for elements, and that way we know, even if I had, say, a solid dot and an 8, I'd say that's not this 8 in there, that's the element 8. Well, it'd be nice then if we had a kind of a reaffirming thing to tell us that this is definitely not an element, and I use a square bracket. It's a bit like area that we use. I use it also for area. Now I don't know whether I picked that up, I just developed that myself, but it's something, or whether I read it somewhere. Something I could find out by just asking, finding out. But that's what I do, and that's what I'd recommend you do. Okay, so it's just an extra safeguard to make sure you don't get confused. That's the end of that one. Okay, that's the end of the whole paper too. I have to go and feed my cat. We'll very quickly grade this. Oh my god, where's those 22 x's? Yeah, well they got 5 and that's all that counts. So they used algebra, I used number. This thing about number and algebra, it comes up in linear and sequence. What I don't like about the fact you used algebra again is that this doesn't belong in the algebra part of the course, it belongs in the number part of the course. Okay, so the idea is we don't have to introduce algebra. The really important thing is that 5 there. Okay, we got it right. And so this is 10 out of 10. A lot of students find algebra complicated. So if we need to use it, we can use it, but we definitely didn't need to use it there. What I could do just before I close it up is write down the calculation I did. And I could bars at the side of it to say what's the size of that. It's 5. Okay, because I've taken away more than what was in there, or else I could just do it in 5 minus 5, and that implies 5 needed in intersection. Okay, it seems like just 10 and 5. What's the 10 for? I think that's the only part of the answer. It's not the only question. Work it out. So that's the only part of the answer. So for that you get 10 out of 10. Oh, 5 up here, of course. Okay, yeah, I didn't even check did we get these right. So A without the union, great. Union without the intersection. Look, there's an alternative. A without B, unionized with B without A. Okay, that's cool as well, the second one. But I like this one more, it's simpler. Okay, so we got 5 here, 10 here. That's 15. And I'll fill in the other values and grade my paper later. 15. I'll do that in a separate video. Okay, that's all for now, lads. I'll see you in the next one. So at the end of your pre. See you in the next one.